dimensional close packing. This can be obtained by building the layers on square packed and hexagonal close packed arrangement of the first layer. Let us start it with two-dimensional square close packed layer. When we place the second layer over the first layer of the square close packed arrangement, we find that the second layer is just exactly above those of first layer. The spheres of both layers are perfectly aligned horizontally as well as vertically. Similarly, we may place more layers one above the other. If the arrangement of sphere in the first layer is A type, the other layer will be also the A type. Here, to get the coordination number of the sphere, we find that it is the 4 layer. If we just consider the one sphere at the center, then the 4 spheres are surrounding it, and the one is above and other is below it. Right, so the coordination number, the two-dimensional square close packed, will be 6. That is, when the three-dimensional close packing is done from the two-dimensional square close packed layer, the coordination number is obtained is 6. It is a AAA type of arrangement, and the simple cubic packing is obtained, and its unit cell is the primitive unit cell. Now, when we obtain the three-dimensional close packing from two-dimensional hexagonal close packed layer, we find that there are some empty spaces or hollow spaces which are called voids on the first layer. These voids are all triangular voids. Right? Now you will see that we are going to mark these triangular voids as A and B. Now, when we place the second layer over the first layer, we will either cover the A voids or the B voids. Now, one of the voids, when they are being covered, right, the second layer which has been placed is the B layer. Now, we will find that when the second layer is been placed, we obtain another type of void, right, which is shown in the diagram by the white dots. The voids which have been obtained when a second layer is placed over the first layer, right, it is a tetrahedron voids or a tetrahedral void. And the second type of void is the octahedral void. Now, these two voids are obtained whenever a sphere of second layer, we can say that whenever a second layer is placed over the first layer, we get the voids which will be either a tetrahedral void or it will be an octahedral void. And on the first layer, we have only triangular voids. Now, what is a tetrahedral void? A tetrahedral void is a void in which the center of the 4 spheres are joined, right? And the void is been surrounded by the 4 spheres. Now the next type of void is the octahedral void. Now such voids are surrounded by 6 spheres and are called octahedral voids. Now in case we need to calculate the number of tetrahedral and octahedral voids in a crystal lattice, we can just by knowing the number of sphere, we can find out that how many tetrahedral and octahedral voids will be present. Now let there are n spheres in the crystal structure. Then the number of octahedral voids generated will be n, and the number of tetrahedral void generated will be double of it, that is 2n. Now when we have to place the third layer over the second layer, we will either cover the tetrahedral voids or will cover the octahedral voids. Now when we place the third layer over the second layer, by covering the tetrahedral voids, the third layer of the spheres may be placed on the tetrahedral voids. In this arrangement, the sphere of the third layer becomes exactly identical to the first layer. We can see here that the first layer is denoted by A, the second layer by B, and the third layer is again denoted by A because they are identical. The first layer is identical with the third layer. Now this pattern is known as AB pattern, and this type of packing is known as hexagonal close packing or HCP. Metals like magnesium, molybdenum, beryllium, zinc, etc. adopt this type of arrangement. Now, in HCP arrangement or packing, each sphere is in contact with 12 other spheres. Now, if you just see at the center, right, we have got the one sphere which is surrounded by the 6 spheres in the middle, and the 3 sphere will be above it and the 3 spheres below it. So the coordination number comes to be 12. So when it is an HCP arrangement, the coordination number will be 12. Now when we cover the octahedral void, now when the spheres of the third layer covers the octahedral voids, which are shown here by dotted circle, right, a new layer is formed, which is the C layer, which is neither identical with the first layer nor with the second layer. It's completely different. A new layer is been formed, and the fourth layer, which will be placed over the third layer, will be identical with the A first layer. So it is known as ABC pattern. The pattern is also known as cubic closed packed or face centered cubic structure. It is abbreviated as CCP. Metals like copper, iron, nickel, aluminium, gold, and silver crystallizes in this type of structure. Both type of packings are equally economical. The first is the HCP packing, HCP arrangement. Second is a cubic closed packing or the arrangement, which is also known as face-centered cubic arrangement. They both are economical, though they have got different forms, and in both cases 75.4% is the packing efficiency. or we can say that 74% of the available volume is occupied by the spheres. Now each sphere in FCC again is in contact with the 12 other sphere. Hence the coordination number will be 12.